Hey, hello, and welcome to the show. It's me, JP, and it's time for another episode of JP's Product Pick of the Week. Here we are, and it is Tuesday when we traditionally do this show. Thanks, everyone, for stopping by. We've got some people over in the YouTube chat, a lot of people over in the YouTube chat today. Hello. John and Anthony, Chad, Chase, Anthony, Bill, Complex Split, John O, Gary T, Anthony, Banter, Tackle the World, Dave Odessa, Johnny Bergdahl, Connor. Welcome, everyone. And I don't have to say these people's names because you can see them right here. This is our Discord chat. So if you're over on Twitch or Periscope, if that still exists, or LinkedIn Learning, if it's still called that, or any of the other places where we are broadcasting, you're wondering where's all the chat going on, it's right here, right there. That's at our Discord, and that's adafruit.it/Discord. Go to the live broadcast chat channel, and you can jump into the chat there. So, cool product here today. Let's dive in. So, before I say anything about this, I'm going to send you to the product page, which is that URL right there, and that QR code if you use that sort of thing. Hello, Liz. Liz just joined over in the chat. And if you head to this page, you will see the product pick of the week. So that's going to be an early spoiler there. Spoiler alert. But you'll also see that it is half off today. So you can put this in your cart. No coupon code needed. When you buy it, you get it for half price, up to 10, maximum of 10 per person, probably per address. I don't know. And do it during the show, because pretty soon after the show, it goes back to its full price. So before I say any more, however, I will have Lady Ada tell us about it from her new product video. Take it away, Lady Ada.
We've got finally, after many years, the NAU7802 strain gauge ADC. It's a Wheatstone Bridge ADC, very precise differential input that's designed for strain gauges, but you could probably use it for other sensors as well. This was a product that we actually started designing right before COVID, and then COVID hit. We kind of got busy designing ventilators and face shields, and then we went back to the design. The chip wasn't available, but we did get a shipment finally of these chips, and so I wanted to get this STEMMA QT board out because we sell strain gauges. You'll want to read them, and this is a great I2C strain gauge reader. It comes with the Nuvoton NAU7802. This is a 24-bit ADC. We only expose one of the ADC lines because most people are using this with a strain gauge that, you only need one ADC. E- and E+ are the two exciter sides of the Wheatstone Bridge. So left, E- is ground. E+ connects to the voltage output from the NAU. It can generate a voltage between like 2.0 and 4.3 volts. Reason for that is I think you can get a nice clean voltage reference. There's STEMMA QT ports, so you can just plug it into your microcontroller board or microcomputer. We've got Arduino code, which I've got on the demo that I'll show, that Jelly also showed very kindly. And there's also from Cedar Grove a great CircuitPython/Python library that you could use with a CircuitPython board or like a Raspberry Pi or something. So let me show you how it works. So you connect the 4 points of the Wheatstone Bridge, strain gauge in this case, to the sensor. I actually have the exciter and ADC pins backwards, but it's okay because the Wheatstone Bridge is actually symmetric, so it doesn't matter. And then I have some Arduino code working on this feather that I just have plugged in. And you'll see I have the gain up really high, so you'll see like even me touching this makes the number kind of go up and down because I'm applying a little bit of strain, just picking it up. If I set it down, it'll kind of stabilize a lot more. And then of course you can add more filtering on top. But then if I apply strain, you can see I'm so strong. And then the other way, it makes a negative number because it's a differential reader. So, of course, you can measure if, positive or negative change in current through the resistive bridge that is attached to this chunk of metal. This is a 1 kilogram strain gauge. I haven't actually tried it with other Wheatstone bridges, but there's absolutely no reason it wouldn't work with others. So if you have other projects that need a 24-bit ADC and you're okay with, it's not going to go that fast. I'm running this at about 10 hertz to get good precision out of it, but I think it goes up to about 300. I think you probably lose a few bits of resolution at 300. That's the trade-off. It's an inexpensive board that's designed for slow measurements of weight. And there you go.
Yes, that's right. That is it. Let me show you it in my downshooter here. This is my very own one. I actually have a couple of these. And these are the little screw terminal blocks that come with it. This is my product pick of the week. It is the NAU7802 24-bit ADC. It's stemma QT and it's used for strain gauges and load cells with a Wheatstone bridge arrangement. In other words, it's perfect for making scales. So let me show you first a real simple demo and then a really cool, more advanced one. So we'll jump into, how about this view here? And I'm going to rearrange my camera a little bit so that you can see a couple things going on. I'm going to pull the terminal blocks out of there. So here you can see I've got the NAU7802 plugged in over I2C to a little Feather NRF52840, a little Feather RP2040 there. And then you can see I'm using some crimp connectors connected up to a load cell. Looks a lot like this one, except this one I have mounted to a little metal plate, and I've added a little sort of place to set something that you're weighing. So if you take a look at my, there we go. If you take a look at my little serial output there, as I press on this little plate, you'll see that the raw channel value is going up and up and up as I'm putting more and more pressure on it. And then when I reduce, it goes back to it's zero state. This is a little higher than zero, but I didn't recalibrate this one. So the way this is being read right now, if you take a look at my code, is simply with this read raw value command. So NAU7802 channel 1, there read raw value, and that is giving us this raw 24-bit value here. Now, the cool thing about this, it has, like I said, a high resolution. It's 24-bit. There's a gain circuit on board, which allows you to make really precise measurements of tiny little changes in the current of this Wheatstone bridge resistor arrangement that's built into the load cell there. It runs over stemma QT, which makes it easy, I2C, so you can plug it into a quick or stemma QT slot or any other I2C pins that you have. Those pins are broken out, by the way, so we have not only the I2C ports, but also a little set of pins broken out at the bottom. And there are Arduino and CircuitPython libraries for it. So this example I'm using here is using the CircuitPython library right there that Cedar Grove made, our very own Cedar Grove. So thank him over in the chat. Thank you, Cedar Grove. Cedar Grove NAU7802. Import that, and then we're able to address, actually there are 2 channels on this chip. We only have 1 broken out on here. So in this case, I'm just going to use a single channel to look at that. Now, one of the things I'm really excited about is a much more elaborate example here. So let me rearrange some things here. I'm sorry, that was a bit out of focus there, wasn't it? I moved the camera and forgot to focus. All right. So this will take some setting up. So I'm going to unplug power, and I'm going to unplug my little stemma QT cable. Remember, don't go unplugging I2C stuff while there's power on. And now I'm going to take a clue and plug that in, again, over the little stemma QT port there. And I built this little scale arrangement for weighing coffee things. So if you're making coffee at a somewhat obsessive level, then you probably want to be weighing your grounds before you make, in my case, espresso. And you also want to weigh the shot rather than time it. You can weigh how much is going into your cup, which means you can use different size cups and you don't have to have graduated markings on them. So this is going to actually become a, based on code that Jan, Mr. Cedar Grove, made for us, a more complete solution where I can weigh the grounds, put them into the portafilter, and then pour the shot and stop it when I get to the volume I want based on this weight. So let me plug this in and show you how this is working. I'm going to give this clue here some power, and this can also run off of battery in the future. So when this boots up, it's going to do a bit of setup. Make it so you can see it pretty well. That should work. And then we get this really nice graphic that Cedar Grove made, a little BMP with some text on there and some settings values. I'm going to futz with this until it's clear. And almost, come on, oh. Very nearly clear. Okay, we'll go with that. So now what I'll do is I will take a container that I want to pour my coffee beans into, in this case. I'm going to set that on the little tray that I bolted to the load cell. And now I'm going to tear this scale. I'm going to hold the button there. It's going to remove the weight that it sees on there from the starting point. So now we're at 0, basically. And now I can take some coffee beans. I tend to grind one shot at a time, so I weigh the beans rather than the grounds coming out of my grinder. And so what I'm going to go for the double shot basket that I have on my portafilter there, I'm going to go for 18 grams of beans. So I'll start pouring these in, and you'll see that the weight is going up and up. 18. Oh, I went a little over. I'll pull some out of there. You'll actually see. Let me put some in hand one at a time. Each bean weighs about 0.2 grams, so you can get close. Oh, I nailed it. Okay, watch this. I'm going to put one bean in, and you can see it's really precise measurement. That went up to 18.1 from 18. The more complete version of the project also will beep when you reach certain weight levels, so you can grind into it and just stop when you hear the beep. You should get pretty close. Same with pouring the shot. And so the code for this is actually going to be coming. I believe there will be a guide. There's also code up on Cedar Grove Makers GitHub, which we can probably put over in the chat. In fact, let me bring up my chat window there so I can see if that's been posted. Not yet, but I bet that's coming. So to explain this a little more, there's some questions over in the YouTube chat. This is the load cell, and it has 4 wires coming from it. It has 2 that are power and ground, and 2 that are running through this arrangement that's called a Wheatstone bridge, and that's actually explained in the Learn Guide. If you take a look here, I'll bring that up. So in the Learn Guide here for the NAU7802, there's a link here that says Wheatstone Bridge Arrangement, and then there's a Wikipedia article about how current is measured in these 2 sort of S-shaped arrangement of 4 resistors, or 2 resistor pairs. And so there's a differential between these as we flex in one direction or another. It's changing the resistance in a way that can be measured really, really precisely. There was also a question about could you measure something more flexible? Yeah, I think you can do more traditional flex sensors with this if they are 4-wire type. Someone wanted to say, could you measure something flexible like a fishing pole and see like how heavy is this fish, or how hard is it pulling before you get it up and out of the water? I believe that's possible, but these are the ones that I've seen most frequently. There was also a question about getting these. These don't come with the NAU7802, but we have a few different ones available. They're not expensive, about $4. You can get them in different weight ratings. So the ones I'm using on the scale are the 1 kilogram. We also have a 5 and a 10 and a 20. So depending on what you're trying to weigh, you can probably get these in other denominations elsewhere, but these are the ones that we have here at Adafruit. So not too expensive, about $4 per, I think, for any of those. So let's see. Yeah, Chad Lawson says, I want to build a small scale for the dog's water bowl to fill with an ESP-based device to send a signal to Home Assistant when I need to fill it. This is perfect for that. And in fact, if we take a look in the Learn guide here for NAU7802, you'll see there's two guides that come up. One is the guide for the product itself. The other is a pet food scale that Liz Clark made with City DIY. So here's a whole guide on doing something similar to what you've said here. So using a, in this case, ESP32S2, which gives you Wi-Fi potentially if you want to connect this up to Adafruit IO or another thing like Home Assistant. And it uses the NAU7802 and a strain gauge load cell to measure the weight of the pet food on top. Really great project, very complete, allows you to do things like calibrating and setting different modes using the buttons on front. Another thing I'll mention actually that I found interesting with these, when I went to build, actually let me show you the one here that I've built. I'm going to swap cameras again. Let's go back to here and here. And you know what I'm going to do? Let me unplug this, and I'm going to grab a driver for that. I hope it's this one. These are interesting because they use actually two different hole sizes that are tapped for essentially the base side and the weight side. Now this is somewhat arbitrary, but if you're manufacturing things, this is probably important. I think it would work. You could call one the sort of base of it that's non-moving, and the other side the moving side. But with the wiring coming out of here, this is kind of convenient to consider the thing that's tied to your non-moving part, your bench or your plate of metal in this case. This one's tapped for M5. These are two M5 screw holes. This one is tapped for M4. They could have not done that, but it's kind of neat as long as you happen to have M5 and 4 screws, which I did around the workshop. And what you want to do is you want to give yourself a little distance from the base there, right? So it can still flex. So you'll see I've put it up on a couple of washers there. It's not easy to show. There you can see that air? You need to make sure you have enough air there for this thing to flex just a little bit. It doesn't flex much, but flex enough without bumping into something. So, and this just happens to be one of our little helping hands trays that we have. All right, let's see. Anything else? Any other questions in the chat? Bye, Connor. Connor had to run over in the YouTube chat. And over in our Discord, let's see. Oh, I think there's some good explanations coming our way over in the Discord. Thank you. Yes, Grover. So this library is in the community bundle, so you can use circup install cgrove. No, CircuitPython AAU7802. I think that'll install it. Yeah, Todd mentioned it there. Circup install cedargrove _ NAU7802, and that'll install it nice and easy. Let's see. Jenisku asks if you can measure a spring with that. I don't know. I don't know if you can. You could probably do that, is my guess, with the proper arrangement of springs and or rather with the resistors, the pairs of resistors, but I don't know. That's a good question. Could be a good science project. Let's see. If that is it, then I think we'll wrap it up. So let's jump back over to the product page there. Where'd you go? There you are. So that's product pick this week. It is this NAU7802. It's 24-bit ADC. Head to the product page. You get it for $2.97, then pick up a load cell, and you're good to go. If you want to use 2 of these, unfortunately, there's only one I2C address for this chip, so you'll need to use an I2C multiplexer. We have one that would allow you to multiplex 2 I2C devices that have the same address, so you can't just run 2 of these on a single I2C port, or presumably you could use two I2C ports if your microcontroller allows for that. So that's another option. All right, well, I think then it's time to wrap it up. Let me grab this one, and where did I lose the cable I was going to use to hang it to? It's here somewhere. We'll grab this longer one. All right. Bear with me. Plug it into itself. Okay. That's my product pick of the week this week. It is the NAU7802 24-bit ADC for measuring strain gauges and load cells. For Adafruit Industries, I'm John Park. This has been JP's product pick of the week. Thanks everyone for stopping by. I will see you next time. Bye-bye.